Our last topic for this unit is intersecting chords, secants, and tangents. We discussed something that looked like this earlier in the unit, but we were focusing on the angle measures. This time we're going to be focusing on the segment lengths. So there are three types of intersections that can happen. One would be either two intersecting chords or secants that intersect inside the circle. When that happens, there are four segments created. To find any missing segment length, you will set up the equation A times B equals C times D. Make sure you're looking at the picture for this. So you're going to take the value of A and multiply it by B. Those are the two parts of that single chord. And then you will set it equal to C times D, which are the other two parts of the other chord. Another way that you can look at that, instead of using variables, is you can say part times part equals part times part. The second scenario that can happen is that you have two secants that intersect outside the circle. When that happens, you will look at one secant. So I'm going to use A. So you're going to take A, and then you're going to multiply it by the length of the entire segment, which would be A plus B. So A is the outside length, B is the inside length, but the whole length would be A plus B. Then you will look at the other secant. Its outside length is C, its inside length is D, the whole length would be C plus D. So the equation that you'll use is the whole A times the equation that you would use would be the outside length A times the whole length A plus B equals the other outside length C times the whole length, which is C plus D. In words, whole length times outside length equals whole length times outside length. The final scenario that you can see is a secant and a tangent. When that happens, the tangent squared, so A squared, will equal the outside length B times the whole length, which would be B plus C. So the whole tangent squared equals the whole length times the outside length. So for these first two problems, we're looking at type 1. We have chords that intersect inside the circle. So we are going to multiply the parts of each chord and set them equal to each other. So on the one on the left, I'm going to take my two parts, 27 and x plus 5, and I'm going to multiply those together. So I'm going to do 27 times x plus 5. And then I'm going to take the other chord and I'm going to multiply those parts together. So 24 and x plus 7. And then we're going to solve like we would any linear equation. We're going to distribute 27 times x is 27x. 27 times 5 is 135. Then I'm going to distribute 24. 24 times x is 24x. 24 times 7 is 168. Now we're going to move the 24x to the left side by subtracting it. And we're going to move the 135 to the right side also by subtracting it. Combine like terms, that's going to give me 3x equals 33. divide both sides by 3, and that gives me x equals 11, which is what they asked us to find in this problem. So the second problem is going to be very similar, but this time we're looking for the length of TQ. So we know right now that TQ is 2x plus 1, so to find the actual length of TQ, I need to solve for x and then plug it back in. So to do this one, I'm going to do the same thing. I'm going to take my parts. So I'm going to do 18 times 2x minus 5, and I'm going to set it equal to 14 times 2x plus 1. And it doesn't matter what side you put them on. So you could have done 14 times 2x plus 1 equals 18 times 2x minus 5. It just depends on how you decided to write it. It does matter. You have to keep it consistent within the chord. So if you use 18, you have to multiply it by 2x minus 5 because they're part of the same chord. And when you use 14, you have to multiply it by 2x plus 1 because they are also part of the same chord. So don't mix and match the chords. It has to be the parts of the chord. So now we're going to distribute. So 18 times 2 is 36x, and 18 times 5 is 90. Then I'm going to distribute the 14. 14 times 2x is 28x, and 14 times 1 is 14. So I'm going to move 28x to the left side by subtracting it, and move negative 90 to the right side by adding it. And that is going to give me 36 minus 28 is going to be 8x equals 14 plus 90 is going to be 104. Divide both sides by 8. So 104 divided by 8 is 13. That's not the answer we're looking for. That's just x. To find TQ, I've got to plug 13 back in for 2x plus 1. So I'm going to do 2 times 13, which is 26, and add 1. So TQ is going to be 27. All right. Our next two examples are type 2. And the reason they're type 2 is because they are two intersecting secants outside the circle. So in order to do these, we need to identify the length of the outside part, which should be pretty straightforward, but then also the length of the entire secant. So let's start on this one, the one on the left. Let's start with this top secant. Okay. So the outside length is 8. And the entire length would be if I combine those. So 8 plus 3x plus 4, which would be 3x plus 12. So I'm going to multiply 8 times 3x plus 12. Now if I look at the bottom secant, the outside length is 7. And the whole length of that would be 7 plus 5x plus 2. So if I combine like terms, that's 5x plus 9. So I'm going to multiply 7 times 5x plus 9. So I'm multiplying the outside length times the whole length. Now it should look just like the other problems that we just did. So I'm going to distribute 8x, so 8 times 3x would be 24x, and 8 times 12 is 96. 7 times 5x is 35x, and 7 times 9 is 63. Now we're going to move the 35x by subtracting. That gets rid of it on the right side. Subtract the 96 from both sides to move it to the right side. So that will be negative 11x. And that is going to equal 63 minus 96, which is negative 33. Now we're going to divide both sides by negative 11. and x will equal 3, and that's what it was asking us to find. In the next example, we are not stopping with x, we are finding the length of yz. So we will need to go back in and plug x in to find the length of yz. So we're still going to use the same setup. So I'm going to look at, we'll just do xz first. Okay, so the outside length of xz is 15. The whole length of xz is 15 plus x minus 1. So if I combine my terms, that would be x plus 14. So outside is 15, whole length is x plus 14. And that should equal, let's look at the other secant. All right, xv. The outside length of xv would be xw, which is 12. And the whole length, if I combined x plus 8 and 12 together, would be x plus 20. So I'm going to multiply 12 times x plus 20. Again, the outside length times the entire length will equal the other outside length times the entire length. So I'm going to distribute now. 15 times x is 15x. 15 times 14 is 210. 12 times x is 12x. And 12 times 20 is 240. Let's move our 12x by subtracting it. And let's move our 210 by also subtracting it. So that is going to give us 3x equals 30. We're going to divide both sides by 3, which means x equals 10. Remember, our goal was to find yz, and yz is this length right here, which is x minus 1. So if I plug 10 in, 10 minus 1 is just 9. So the length of yz is 9. Our last two examples are type 3 problems. The reason that you know that is because you have one secant and one tangent that intersect outside the circle. So to do these types of problems, you're going to take the tangent squared and set it equal to the outside length times the whole length. So if we're looking at the problem on the left, our tangent is 24. So I'm going to start by doing 24 squared. And again, you can start with the secant. You don't have to start with the tangent. Equals the outside length of the secant is 18. But the whole length of the secant would be 18 plus x. Make sure you don't multiply here. You're adding the two sides together. So I'm going to do 18 times x plus 18. So we need to do 24 squared, which is 576. And then distribute that 18. 18 times x is 18x. And 18 times 18 is 324. I'm going to move that 324 to the other side by subtracting it. That's going to give us 252 equals 18x. We're going to divide both sides by 18. And that's going to give us x equals 14, which this is what this question was asking for, was x. On the second example, we're looking for Pn. So after we find x, we will need to substitute back in. All right, so this time I'm going to do it backwards. I'm going to look at the secant first. Again, it doesn't matter. So for my secant, the outside length is 8. So I'm going to start by taking 8. And I need to multiply 8 times the whole length of the secant. The whole length of the secant is 5x minus 1 plus 8. If I add those together, that gives me 5x plus 7. So I'm going to take my outside length 8 and multiply it to my whole length 5x plus 7. That should equal the tangent squared. And that's because on that one, the whole is the same thing as the outside. So it's like doing 16 times 16 or just 16 squared. So now let's distribute the 8. So that gives us 40x plus 56. We're going to do 16 squared, which is 256. We're going to subtract 56 from both sides, which is going to give us 200. And then we're going to divide both sides by 40, which is going to give us 5 for x. 5 is not the length of Pn. We'll need to go back and substitute 5 back in. So Pn is just this part right here, just the 5x minus 1. So I'm going to do 5 times 5 minus 1, so that's 25 minus 1, so Pn is 24. And I didn't say it earlier, but I probably should have. These are all lengths of segments, so make sure you do not include a degree measure. We're not looking for arc measures or angle measures, it's a length. So if we had units, it would be like inches or meters or centimeters. And that is it.